Here is our first video dealing with a problem in projectile motion where an object is traveling in the X and the Y plane initially. So here a rocket takes off at an angle of 40 degrees to the horizon with an initial speed of 60 meters per second. So to give us perspective, it travels with a vector of 60 meters per second, and here's our angle of 40 degrees. Our first step is to break this velocity vector into its components. So we have to solve for the velocity in the Y and the velocity in the X. To solve for the velocity in the Y, we're going to take our initial velocity, 60 meters per second, and multiply it by the sine of theta. The reason we use sine is because we're trying to find the opposite component to our angle of 40 degrees. So when we do 60 times the sine of 40, we get a velocity of 38.6 meters per second. Solving for our velocity in the X, once again, 60 meters per second. Now I'm looking for the component that is adjacent to my angle, so I'm going to use cosine. 60 times the cosine of 40 degrees gives us an answer of 45.96 meters per second. All right, so we've broken our velocity into its X and Y components. We no longer need that 60 meters per second. We don't use that anymore in the problem. Next, we need to solve for the total time the object is in the air. In order to do that, we're going to break it down into two parts. Just like in one-dimensional motion, the time it takes to go up is the same as it takes to go down. So to solve for the time it takes to go up, we use our equation v equals v naught plus acceleration times time. Well, what's my final velocity going to be at the top? It's going to be 0. So then I just rearrange my equation to say negative v naught is equal to acceleration times time. And if I divide by acceleration, I'm just left with time. Now this is the time it takes to go up, but since we're looking for time total, then t total would just be 2 times v naught divided by our acceleration. And since gravity is negative, these two negative signs here and here cancel each other out. So we're going to solve for our t total on that 2 times 38.6 divided by 10 gave us a total time of 7.72 seconds that we were in the air for. Alright, while we were in the air for 7.72 seconds, how would we describe our horizontal velocity? There's no force acting on it, so it's just going to remain unchanged. So whatever we start off with as our horizontal velocity is going to remain the same all throughout. So in order to solve for our change in x is no more than our velocity in x times t total. So we just take our two values, velocity in the x of 45.96 meters per second multiplied by 7.72 seconds, and we get a final answer of 354 meters for our range. All right.